session changes today. And we will repeat, first we will repeat the session building a scalable web application with Google App Engine at 12:45, which I guess is now, in room 8. So I hope not too many of you are in the wrong room. We have rescheduled surprisingly Rock and JavaScript and DOM programming in GWT, which will take place at 2 o'clock in room 9. We've also added a repeat session of Under the Covers of the Google App Engine Data Store, which will take place at 3:15 in room 8. And all of our sessions, except for the fireside chats, will be posted by mid-next week on the Google I/O website. So as always, please remember to fill out your evaluation form and leave it in the collection bin at the back of the room. So that's enough of the canned content, so now let's move on to my content. So thanks for coming today. My name is Dan Morrill. I am a developer advocate with Google, and I'm here today to tell you a little bit about the Android application framework. So this is actually a session that I'm pretty excited about because this has got some content in here that we have not yet really documented that well. So there should be some interesting concepts in here that some developers may have kind of picked up on their own, but for the most part, this is, I think, one of the first times that we've really talked about this in public. So I'm hoping that you guys get a lot out of this today, and I would definitely be interested in hearing what your thoughts are at the end of the session. So to get started, the first thing I want to point out is just start with a really high-level observation. Android is not just an API, it's not just a framework, it's actually a complete operating system. How many people here went to Patrick Brady's session yesterday about the Android and anatomy and physiology? Anybody go? Okay, great. So if you attended that session, you might remember that he had this sort of placeholder for what goes on in the actual application framework, and this is the content that goes in that placeholder. But one thing that you hopefully picked up from that session, or if you didn't, I encourage you to check that out when it goes online, is that there's a whole lot more to Android than just a programming environment. For the most part, for developers, though, that is abstracted away. We don't want developers to have to necessarily be super aware that there are processes and all sorts of things like that going on. We try and make the API as transparent as we can, but in some cases we just can't do that, and so there are seams where pieces of the abstraction kind of leak a little bit. So what I want to do today, really at a high level, is just to identify those seams and demystify them a little bit, because sometimes it can be a little hard to figure out how a lot of these pieces work together. So to take it a step down, Android is essentially about managed components. So if you want to know what an APK is, which is of course the file that you as developers create and then install on a device, an APK is an Android package, and it is no more and no less than a collection of components. It's not an application. It can contain an application. There's some interesting things that we can say about that I will in just a moment. But the key thing to remember is that think of the system as a great sea of components, and each APK is sort of an island in that sea. Each component that lives on one of these islands cannot cross over to a different island. But as far as they're concerned, it looks like they can. What's happening is the system is creating bridges underneath them as they try and get from island to island. So on their island, however, these applications share components. They share things like file accesses, preferences, database instances, and of course, a Linux process, which is something that will come up several times throughout my presentation today. And then the final thing to recognize, just to get started, is that each one of these component types has a managed lifecycle, has a very defined series of steps that it goes through. So first, let's talk about the basics of an application. Now, I just said that an APK is not an application. So what is? Well, before I can answer that, I want to define 3 things. I want to define an activity. An activity is what I like to call a molecule because it's more than an atom, but it's less than like an actual object. Then there's this notion of a task, which is a collection of activities, and then there's this process, which is exactly a standard Linux process. So I want to just depict this for you real quick and before I get into too much detail. So here we have an APK, and this is one of those islands in the sea that I just described. Each APK is associated with a process. So you have a process that contains or is the process in which all of your APK's components execute. An example would be activities. They execute in the process. Content providers execute in the context of the same process, and so do services. Meanwhile, you can have a separate APK will have a separate set of resources, and as I've depicted in this one, developers who choose to do so actually can cause certain things, such as services, to run in a process of their own. However, that's fairly uncommon that you need to do that. So this is at a high level how things are structured and how they're packaged. But then there's this notion of a task, and the question is, well, what is a task? A task is a collection of activities. So let me define these in a bit more detail. Activity is a concrete class in the API. What I mean by that is if you go to our website and look at our API documentation, you can find the documentation for the activity class. If you look in Eclipse or another IDE and you poke around in there, you will find activity as an actual class. It's an encapsulation of a particular operation, and that's why it's called activity and not application or something like that. Activities actually do not have to have a user interface. They can just do something. They can just take some action in response to an intent that gets issued. So they're optionally associated with a windowing object, but the big thing is that they are an execution context of their own. And what that means is the context is the mechanism in the Android framework that you use to access other resources. So you use the context to do things like get handles to system services, bind to services, and things like that. So the activity, in other words, is a very clearly, semantically, strictly defined component in the framework. A task, however, is not. A task is little more than a notion, really. It's not a concrete API, but what it is essentially a runtime record of a sequence of activities. A classic example, of course, is using the browser. If you create an activity, you as a developer create an activity, it will appear in the user's home screen. So the user, touches that or, uses the directional pad or a trackball or something like that. They select your icon, they launch it, and what that does is that causes an intent to be fired, which causes your activity to launch. Most of the time, your activity specifies a user interface, and so that's what appears on the screen in front of the users. That activity may, do some other activity and create another one. And so you get this layer of activities, this stack of them. At the back, you have the first one, and then, in front of it, you have the one that the first one launched. And so if you have the child activity itself do something like display a web page, what you end up with is your first activity, your second activity, and then the browser. And this is literally a stack, and the system tracks these as a stack. And if you use the emulator, you'll know that there's a back button in there. And when you hit that back button, what it's doing is popping essentially entries off that stack. But the key thing to realize is that, oops, I went too far. The key thing to remember here is that tasks can span activities. And each task is what the user is going to likely think of as an application. So if you've got a user who's coming to the system from a desktop metaphor, they're used to clicking on that icon and thinking of a program starting and having the program do its thing. In Android's case, we've got this sea of components, and you can define an application including not only your own components, but essentially pulling in components from other APKs as well. And the key thing to remember is as this image depicts, some of these activities don't need to belong to you, and if they don't belong to you, they actually will run in the context in a separate process in the context of the APK which installed them. So then there's this notion of a process, and how does this play? Well, there's no magic about Android processes. They are quite literally simply Linux processes. There's no magic, there's no additional semantics on top of that. And by default, there is one process per APK, and that process is essentially treated as one of the resources associated with or owned by that installed APK. By default, there's one thread per process, and this is actually probably the least intuitive thing about Android to developers coming from a more traditional desktop or in some cases mobile background. There actually is one thread by default for the entire process, and all of your APK components run in that thread for values of all equal to most. There are some exceptions to that, and I'll talk about those a bit later. So how does this process then get started? When and why? Well, the short version is really that processes on Android get started whenever they're required. So what this essentially means is that any time the user or some other system component requests that code belonging to your APK get executed, and that can be a service or a content provider or an intent receiver or an activity, it can be any of these things. Anytime something in the system wants your code to run, the system will spin up your process if it's not already running. And in general, processes remain running until they're killed by the system. And this is something that as a developer you should never really need to know about or worry about. Processes are created on demand, but just as a behind-the-scenes sort of thing, for efficiency purposes, the system will keep the process running until it decides it needs to kill it, even if all of the components in your application are actually concluded and shut down. Now, it may not keep them running for long, but it has that option to keep it running for efficiency. So activities are, probably the component that developers interact with the most, and they also have the most complex life cycle. And so what I want to do now is spend some time talking about the specific nuances of how this system works. Now, I had a professor in college who said that, one day when I complained to him, I said something like, I don't understand how mathematicians can do this. I think this was when I was taking Calc 3 or something like that, and I said, I'm taking Calc 3, and I've already forgotten half of the stuff I learned in Calculus 1, and now, I have to take these other math courses as well, and, how do you mathematicians do this? And he said, well, he made an analogy to carpenters. He said a carpenter doesn't need to know how to use or master every single tool in his toolbox, but he does have to know, what the tools are for, so that, if he wants to, plane a board or something like that, he's got to know which tool is the planer, and he's got to know how to figure out how to use it. And I don't think that's a concept that will be alien to anybody in this room. So what I want to do today is just kind of talk about these, various life cycle methods that you see up here, explain what they're for, and I don't necessarily expect you guys to have a total deep understanding of the ins and outs, but what I do hope that you come away with is, an understanding of what they're for, when they might get invoked, and, which ones you should be interested in developing your app. So what I want to do, though, is break them up at first into 3 general groups. And I want to stress that these groups are strictly, for explanation purposes. This is not like a system notion. The system doesn't have any understanding of these or attach any significance to this grouping. But that said, the first sort of logical grouping of these things is what I'm going to call the startup phase. And these essentially correspond to you exist, you are on the run list, and you have focus. So what I mean by that is the way that the actual object lifecycle works is the system will actually instantiate and call a constructor on your class, but of course that's not considered one of the lifecycle methods, so as is fairly common in Java, in frameworks for the Java language, the constructor isn't where a lot of the magic happens. Instead, you have this method called onCreate. And what this is doing is this is essentially a signal or a notification to your application that that your application now exists and it should initialize whatever resources it requires. So in onCreate, you're typically going to do things like connect to your database and that sort of thing. OnStart says, okay, you now not only do you exist, but now you're essentially on the run list. You can start executing at any time. This is where you're going to want to do things like last-minute initialization, like setting up animations and that sort of thing. If you think that there's sort of an intuitive ambiguity between what the meaning of onCreate and what the meaning of onStart is, you're right, but I'll show you, why onStart exists separately anyway in a few moments. A related method is onRestart, which is something that I'll also explain in a few minutes. So then there's onResume, and what onResume means basically is that your application is now at the top of the stack. In other words, it's visible to the user, and it has focus for input elements. So that's sort of the I don't exist to I am running startup phase. Then there's sort of the normal execution, and these methods are ones that you can kind of go back and forth, in and out of, several times through the life cycle of an application. OnFreeze is a method that essentially says you might or are likely to be shut down soon, but for now you're still running. So this method is intended to be a hook for an activity to save its UI state. And I want to stress the fact that it's intended for UI state and not necessarily for data persistence, because data persistence is intended for onPause. So the way that this works is when onFreeze is called, it's basically saying, hey, you might actually be shut down soon. So if you've got a complex dialogue, something like, I'll give an example. So suppose you're a developer and you've written an enterprise application, like an asset tracking application. And so the user has a program that they're running on their phone, and they enter some text into it, and they're doing data entry. And it's a complex form. It's got 40 fields. And the user has perhaps filled out 35 of those fields, but then something happens, like a phone call comes in, or the user switches to a different application, goes on break and opens up the browser or something like that. What onFreeze is intended to be used for is to save the state of that user interface, save the values that are recorded and specifically selected in the fields, and not really to save the record to the database. The record saving to the database is really intended to be used for onPause. So onPause says your application no longer has focus, you're no longer executing at the top of the user interface stack, so go ahead and suspend yourself or do whatever it is that you need to do. And that's an important distinction. It's one of those sort of subtleties that seems like, well, why are there these two methods when they seem to have a related meaning? So the third kind of logical grouping is the shutdown phase, which basically comes down to onStop and onDestroy. The thing about these methods is that these are, in general, not guaranteed to be called. You'll generally get them if your application has called finish on itself, which is another way of saying explicitly telling the system, I am done with what I need to do and terminate me. So you'll get them in that scenario, and you'll get them if somebody else calls finish on you. But if another application comes on top of yours or something like that, you don't necessarily get these methods called. So that's great, and everything I just said, you actually can kind of pick up from the documentation. If you sit there and pore over this table and look at that state machine diagram, you can figure all that out. But what isn't necessarily obvious is exactly when and in what situations these things will actually, in a real world, be invoked. So what I want to do now is based on what I just explained and kind of the high-level description of these methods, I want to give you guys some actual case studies, or use cases rather, and just show you, if you're doing, something like X, what a specific sequence of calls of those lifecycle methods will you actually see in your code. So the first one is, I'm going to start, very simple, very textbook. This is the classic scenario. I've launched an application, and maybe it gets suspended. So what we have is onCreate, which says it's called after, obviously, the object is constructed. It's the first of the lifecycle methods, and it says, please initialize yourself. Then we have onStart, and onStart says, okay, you're now on the run list. You can start executing at any moment. OnResume says, okay, you now have focus. You're now the top-level application. So in between onResume and onFreeze, your application is doing its thing. Maybe you're playing a movie or collecting some input or something like that. Eventually, you'll get this call to onFreeze, which is kind of a warning. It says, hey, heads up, you're about to get suspended. And then onPause is called, which says you are no longer the top of the activity stack and you no longer have focus. And this can happen for a variety of reasons, so don't read into it anything more than that. It just says you no longer have focus. OnStop is called, and in that situation, perhaps the home screen started or an incoming call came or something like that. In other words, your application is now no longer likely to be run in the near future. However, if the system determines that it's not actually going to shut your application down, in other words, it doesn't need to reclaim that memory, it can actually call on restart. And what that means is essentially telling your activity, hey, you're back on the run list, you're back eligible to start executing again, and then you'll have like onStart, onResume, and essentially you'll repeat that life cycle. So this can actually, you can hypothetically anyway go through this many times. In practice, you'll probably only ever see this cycle happen once or twice, but as in terms of the way that the life cycle is defined, you can actually see this several times. So here's a slightly more complicated scenario, which is essentially the same scenario, but in this case, the operating system actually is going to decide that your application is using memory that it needs, and it's going to kill your app. So what happens is we have the same sequence. You exist, please initialize yourself, and the first time onCreate's called is called with empty state. That's an important thing to remember. So first it says you're a clean start, you exist, you're eligible to run, you now have focus, and you're running. Then we have onFreeze, which says, you're likely to be shut down in the near future. Then you have onPause, which says you no longer have focus. And then at that point, after onPause, the system is allowed to just kill your process and never send that instance of your activity any data ever again. So after onPause, you're eligible to be killed. And maybe in some rare kind of corner cases, you'll actually see onStop and onDestroy called. But since the system is likely to, is going to leave processes, around as much as it can, you're only really ever, this scenario is only ever going to be triggered when there's memory pressure anyway. And so it's very rare that you'll actually see onStop and onDestroy called in this particular case. But however, once the user does eventually get around to going back into your application, you'll see this onCreate call, and it will correspond to starting a new instance of your activity. But in this case, you'll get the state that you had the opportunity to save previously, and you can resume that and continue from there. So that's, as I said, a slightly more complicated example. So the next example is what happens when the user hits home. Well, if you look at this and then you compare it to the previous example, they're identical. And that's the point that I want to make with this slide. The home screen is just an activity. It's not a special case in terms of the life cycle. Nothing magical happens, when the home screen appears versus, say, when the user starts another application. Now, this is a slightly different scenario. This is what happens when your application is explicitly finished. So again, we have onCreate and onStart. You exist. You are eligible to be run. We have onResume. You now have focus, and you're executing. Then we have onPause. Well, actually, let me back up. So after onResume, either your code calls finish or some other component calls finish on you. In which case, you then see onPause, as you always do. But then you do see onStop and onDestroy. And the thing to remember about this case is that there's two notable things. First, onFreeze is never called. And the reason is that onFreeze, again, is intended to be a method to save your UI state. But in the case of finish, this is an explicit call that says, this activity is finished. Whatever it's doing is done. And so the system is allowed to assume that there's no need for this activity to save its state because it's being explicitly terminated. And so that's why onFreeze is not called in this scenario, yet onPause is. But then we have onStop and onDestroy. And again, in the case of the finish, onStop and onDestroy almost always are called because it was an explicit termination, and the system basically has the luxury of doing that. And in fact, when you get into the onDestroy method, there's a method that you can call called isFinishing that will return true if you are called in response to a finish command, and will return false otherwise. So what this basically boils down to is something like 99% of the time, in your onDestroy method, if you check the value of onFinish, or the value of isFinishing, it will return true. And that's simply because most of the time when onDestroy ever gets called, it's called in response to an explicit finish. So then there's an example, and this is a very common use case that people like to do. If you want to do something like in a browser, you can create an alert window, which is just kind of a pop-up that says, like a message or something like that. If you do that in an activity, or if you want to do that on Android, Android has a class called Dialog Box that essentially does that functionality. The thing is, that Dialog Box class is actually a view and not an activity, which means that it's essentially, rather than being integrated into whatever layout you've got, it's actually just floating on top of it. But it's still a view, and so it has no impact on the life cycle of the activity that caused it to appear. And that's an important thing to remember, because you can also do this another way, which actually is to create a child activity that does not take up the whole screen and situate that in front of your activity, and that actually would cause the lifecycle methods to be generated. So it's just an important thing to remember that not everything is necessarily an activity in the user interface, so you have to, don't be surprised if you see occasionally unusual things. So for this one, let's consider a scenario where you've got like a media player or a game or something like that, and you've got some kind of active animation going on your screen. In this case, you get onCreate, the three startup methods, you exist, you're eligible to run, and you have focus. However, suppose that a non-full screen or semi-transparent activity appears on top of your activity. This could be like an alert or something like that, either that you created or somebody else created. In that situation, what happens is that your activity is still visible behind the other, the child activity. And so what that means is that you'll get the onFreeze and you'll get the onPause, but you'll never see onStop. So if that activity is dismissed before your application is fully obscured, then what happens is your application again becomes the top of the stack, and immediately after onPause, you get onResume, which says, now you have the focus again and you're eligible to run. So this is a slightly different situation than just having a full screen activity appear, in which case you get a stop invocation because you're totally obscured and you're really not eligible to run anymore. So what this essentially implies is because you're notified that you no longer have focus, but you're not actually stopped, you can still run. So for example, if you're building a media player and you got a movie playing there, it is possible to put an activity that's, say, semi-transparent on top of that and have it continue playing. And you might want to do that if you want to have like a game or something keep playing in the background while you've got an activity that's changing its setting or something like that, so that you don't have to pause the animation. That's a legal use case, but just be careful when you are building an application like that to remember not to surprise the user. It could also be very easy to do the wrong thing and have the user be irritated because their movie is now 30 seconds past where they expected it to have paused or something like that. So use with care, but it's definitely a supported use case. So then there's the use case of what happens if your activity is running while the device goes to sleep. And you can, again, compare this to the previous scenario. And in fact, they're identical. So more or less, as a design decision or a matter of policy, the engineering team said, okay, well, when the device goes to sleep, we're just going to make that case look like you have a semi-transparent activity pop up on top of your activity. Excuse me. So the next one I want to talk about is threads. So I alluded to this earlier when I mentioned that each process has by default only one thread, and most of the components, most of the time, share that same thread. But however, there are cases, and I'm going to talk about these, but sometimes in some scenarios, services and content providers don't. So let me explain a little bit about what this thread is doing before I try and tell you how it's used. Each thread that's running in the process has what's known as a looper. And the looper is basically just a message queue processor. There's a message queue associated with the system, and the looper is just an object that knows how to pop things off that queue and work with them. So all of the system events and UI events and so on, they essentially inject entries into that message queue, and it's the looper's job to process them. Meanwhile, the thread does literally, or almost literally, nothing more than just call the looper.prepare and looper.loop method over and over again in every iteration of its run method. And the thing about loopers is they assume that they are associated with a single process, and so they don't assume that are not even remotely intended to be thread safe. So I'll get into some of the implications of that a bit later. But one thing that people wonder is, well, a very common thing is to say, okay, well, I've got say a physics model, and I want to run that in a child thread. So you're running your simulation in your child thread, and you've got your UI thread over here, and you want to update the contents of the UI. You can't just directly do that, even if the child thread can get a reference to the object, the view object that you want to update. And the reason is that there's one looper, and the looper can't tolerate multi-threaded accesses to it. And so the system will actually throw a warning at you, or an error even if you try and do this. That's why we have this message handler class, which we have included in the system. The way I phrased it here was that the loopers are designed to play nicely with message handlers, but you could also turn that around the other way and say that message handlers know how to play nicely with loopers. And so that's why in our documentation, and if you ask us this, you say, well, how do I build, spawn a child thread? We immediately will tell you, just create a message handler and use that to communicate between threads. So I know that was a lot of words, so I want to depict this for you again. So here we have our package. This is, again, the .apk file that we install, and it comes with a process. And as I said, that process by default has one thread. Within that thread, we have a looper, and the looper is essentially the sole owner of this message queue. So what does the looper do? The looper is what actually invokes methods like on intent received, or actually invokes the lifecycle methods on activities and so on. So the various components that you interact with get invoked by the looper in response to messages in the message queue that come from things like UI events. And this includes things like key presses, touch screen events, screen motion events, and essentially anything that the system decides it needs to alert you about. And then, of course, system events as well. And this is things like somebody broadcasting an intent to you and similar things. Now, what I want to explain, just take a quick moment to explain at this point is, if you've ever built an Android application, you might have seen the dreaded application not responding warning. And what I want to do is kind of explain where that comes from. So what happens is the operating system, is gathering input through the Linux kernel in the usual ways that, if you're familiar at all with Linux, and it takes these events, all the events I just mentioned, the UI events, and basically injects them into an operating system input or input queue. There's a component that essentially takes those and drops them into the message queue for the looper. And then what it does is it records the time that they got added to the queue and periodically looks at that queue and says, if there is an event that has been in that message queue for longer than 5 seconds, it says, okay, obviously you've been in this too long, and the only possible conclusion is that the looper thread is not executing because something in the looper's call stack has blocked the looper. And so the system then says, application not responding, and offers to the user to shut it down. This is exactly analogous to what browsers do with the slow script warning. So if you've ever built an Ajax application, you probably are aware of the fact that in JavaScript, the JavaScript virtual machine is single-threaded, and all of the DOM, UI events, and XML HTTP request events, they all get dropped into this single master queue. And that's a very, very similar analog to what's going on here. So another interesting scenario that actually causes the looper to, or that the looper handles, is calling local service calls. And this is one of the special cases that I talked about earlier. So if you write a service, and again, a service is an Android component that has the opportunity to run in the background if necessary. If that service is running and you bind to it locally, meaning that it's owned by the same APK as an activity that attempts to bind to it, if you do that, then the system looks at that and says that's a local call. And any methods that you call on that service will execute in the same thread context as all of your activities and intent receivers. However, if your service is public and you expect other APKs to use it, if an external APK, published by a different developer, comes along and binds to and makes a method call on your service, the binder, which I'll talk about a little later, and which handles inter-process communications, the binder actually has a thread pool running in your process that it uses to service what I'm going to call extra process service invocations. And the reason it does that is if it didn't do that, it would make it extremely easy to basically deadlock two processes together by, it would be very easy for developers to write code that could deadlock two processes. And so to prevent that, the binder will actually run extra process service calls in a separate thread. And this is something that I touched on earlier. I guess I probably should have put this thread earlier in the sequence, but basically, I just want to reiterate again, if you create a thread and you want to use that to compute some data that you want to put into a view, and this can be anything from like a physics simulation for a game to like executing an HTTP request to fetch some data that you want to use to populate the values in a form. Either of those use cases is going to be a long-running thing, and you might want to do it in a thread. If you do choose to do that, you can't go back directly to the view and update its contents for all the reasons that I said earlier, because Looper is simply not thread safe. But what you can do is you can create your own thread, and if you really want to do something like have two completely separate view stacks running in the same visual context, running in different threads, you actually can do that, but you need to create a looper for your own thread. And you can do that for whatever reason. You can do that just because you want to, or because you want to use a functionality, or whatever. And again, I just mentioned this as well. So I do want to take, and this slide is almost kind of an orphan. I couldn't find a better place to put this slide, so I'm going to put it here. I just want to take a quick moment to talk a little bit more about the life cycle of a service and what that does. So there are two ways to start a service. You can either make an explicit call to the system to say, go start this service for me, or you can make an implicit call just by saying, I want to bind to this service. In the first case, you would do an explicit start service, and that's an example of where you'd want to do something like play an MP3 file in the background. You want to have that service running, and you don't necessarily want it to be shut down. You want it to be long-lived until it's explicitly terminated. The other case would be where you've just got like a body of functionality, like send an email or something like that, and you want to let somebody bind to your service and fire some data into it and have it take some action. In that situation, you're going to want to bind to it implicitly. The difference is that the system, when it spins up a service, if the service was started explicitly, the system will keep that service running until it's explicitly shut down, or in dire cases, until it really, really needs the memory and just kills it outright. Implicitly started services, however, have a reference count on them. So if there's like 5 different APKs that are all running at the same time, bind to a service, 4 of them can terminate or unbind, and that service will still keep running until the last client unbinds, at which point the system will then shut the service down. So it's basically an on-demand thing versus always leave it running. And the implication in the life cycle, or the implication on the process life cycle, is that the process obviously has to be running for the service to be running, and so the process will be kept around as long as the service is. So speaking of processes, I just want to, there's a little bit more to processes than I've covered so far, so I just want to take a few quick slides to talk about these. The first thing I want to talk about is this thing that we call the zygote. And again, if you attended Patrick Brady's session, you might have heard a little bit about this. But really what the zygote does is it's essentially a pre-initialized Dalvik virtual machine. What happens is when the system starts up, it does a fork, and the process it forks is the Zygo process. Zygo loads the Dalvik virtual machine, all the code it requires, loads basically the standard API packages, such as, say, java.util.hashmap or something like that. So it loads up all the core classes, and then it basically just goes to sleep. And then what happens is when a new application is required to start, like the user has selected your activity from the home screen or something, the system sends an intent and then basically sends a message to that process that says, hey, wake up and execute your activity XYZ. So the Zygo process wakes up, does a fork, and then the parent immediately goes back to sleep again, but the child then does essentially an exec and loads the appropriate class for the component that was requested. Now, the reason we do this is for responsiveness. If you think about how long it takes an application to start up, there's a lot of common memory in that kind of thing that would get loaded and reloaded over and over again. So instead we load it once and just basically sit on it for a while until it's needed. And that just makes it a little more responsive, keeps the UI a little snappier from the user's perspective. The other interesting thing about processes is that when an APK is installed, it's actually installed under a unique generated user ID for that APK. And we do this for security reasons. Linux and Unix systems in general are really good at user-level sandboxing, meaning that if you have a file on the file system that's owned by user A, through long years of review and use in practice, Unix is very good at keeping user B from getting access to user A's file or processes or other resources. And so, from the perspective of an operating system like Android, the notion of multiple users on one phone doesn't make a lot of sense. I can't imagine that many people are going to want to have two people sharing one phone, and so we have the situation where we're not using these user IDs for anything else, so we might as well use them for application sandboxing. And that's really kind of the fundament of Android's security model. In fact, I mentioned that each application or each APK gets its own user ID. There are no exceptions to this. Like every single application installed on the system on a production device will have its own APK or its own user ID, and that includes even like the home screen. The implication is that every single one of those runs in its own process and runs in a process owned by its own user ID. In fact, there are only going to be 3 processes that run as root on the production system. One is the init process because it has to run as root. It's just the way Linux works. The other is the Zygote process, and the only reason Zygote runs as root is because when it does that execute arbitrary component, it needs to do a ch user to transform itself into the appropriate user ID, and you can only do that as root. And then the third process that runs at root is the main runtime, which is kind of our collection or our name for the collection of components that, because they're talking to a device driver or writing directly to the frame buffer or the audio hardware or something like that, they need to run as root. And so that's where things like audio flinger, surface flinger, and stuff like that live. So each application has direct access only to its own data, which I mentioned earlier. But the kind of the key big thing here is, in general, if you want to expose data or resources to other processes, you do that through a couple very well specifically defined APIs, namely services and content providers. If you want to expose functionality, you use a service. If you want to expose data, you use a content provider. And what we can do is, by doing it that way and isolating in terms of processes, we can basically build that one bridge, the IPC bridge, that connects 2 processes together and lets them share data and issue commands to each other and so on. We can essentially secure that, review and basically audit the hell out of it, and make sure that it's a very secure piece of software, so that we can make sure that it's safe to make these inter-process calls, and that also helps the security model. So inter-process communication. What is this bridge that I just referred to? But before I get into that, I just want to take a moment to address a quick question, and this comes up with some frequency. If you're a Java developer, sometimes people just want to know why. Like, what is with all this stuff? Why do we have these bundles that I see in this icicle method and onFreeze? And why do we have these multiple processes? Why can't we have everything run in a single gigantic memory space or something like that? And the simple version is speed, or put more accurately, efficiency. We're not really concerned about speed when we say this. People will say, oh, cell phone processors today are at 500 megahertz, and within 2 years they'll be at a gigahertz or 2 gigahertz or something like that. And yeah, that's true, but the thing is that that's not really where the bottleneck is. We're not worried about necessarily CPU cycles. What we're more worried about is things like pipeline stalls as a result of waiting on memory. I think, I mean, what are desktops up to these days? I've lost track. What is it, like QDR is now the, like, or not QDR, like DDR4, DDR3, something like that. There's all these memory standards, and each one gets faster than the previous and so on. But, you don't have DDR1 memory in a cell phone, for one thing. You've got, probably memory standard that you might recognize from 5 or 10 years ago is what's in your cell phone. I've seen, memory bandwidth on the order of 40 megabit floated around, and today on desktops you're looking at 400 or 800 megabit. So the real issue here is memory bandwidth more than processor speed. We're not worried about the clock rate, we're worried about memory transfers. So the fewer memory transfers we can do and the more efficient we can make them, overall, that's going to make our application and our system more responsive. So that's really what this is about. We try and make the processes as transparent as we can, but in some cases we can't, and in a lot of ways we don't want to make the data transfer transparent. And the reason is it is an expensive operation. It always will be, no matter what we do. We've tried very hard to make it as inexpensive as we can, but we still want developers to be aware of the fact that what they're doing is a potentially expensive operation. So what I want to do now is just show you at a high level how the IPC system works. On the left we have the kernel, and that's the kernel doing memory management and so on. And on the right we have the process. We've got this thing called binder, which bridges kernel and process space. And what it is it's a kernel module, an actual Linux kernel module that plugs into the kernel that provides various memory sharing resources that has as its unit of currency the parcel. A parcel is just it's more or less kind of like a C struct or a protocol definition for a sequence of data. And the binder knows how to shuffle parcels around, either store them or save them in memory or share them between processes and things like that. At the framework level, there's this class called Parcelable. And a parcelable is basically an interface that classes can implement to signify that they know how to serialize themselves to a parcel. In other words, a class that is parcelable knows how to write itself into a parcel so that the binder can share it between processes. The most common implementation of Parcelable that developers interact with is a bundle. This is the method that you use in intent receivers, in activities. In an activity, you see a bundle in your onFreeze and onCreate methods. In intent receivers, bundles are kind of implicit. They're the backing that goes on in the data store behind an intent. But you can also define your own custom objects to implement Parcelable. And in that scenario, the reason that you'd want to do that is because you're building a service or something and you want to share data between, or you want to expose functionality to an activity. So that's at a high level how it works. So I already touched on this, but all IPC in the system goes through binder. Binder can handle this both from the Java framework at the Dalvik level, but it can also handle it from native code. So binder is a general purpose IPC mechanism. And it's generally used anytime you need or will potentially need to share data across processes. And this also applies even in onFreeze and onCreate, because the point of onFreeze and onCreate is to save your state because you might get killed. And so, in the case of traditional IPC, you're sharing data between process A and process B, where the two are separated, by memory space. But in the case of onFreeze and onCreate, you're still sharing data between two processes. It's just that you're sharing it between two processes separated in time. In a certain sense, you can sort of think of that as like, passing data to your future self. So I already touched on this. A parcelable is, a class that knows how to save its state to a parcel. But one comment that I want to make on this in addition is just that why we have Parcelable and why we don't, necessarily right now support Java serialization. The reason is that Java serialization, in very general terms, you can describe as a standardized mechanism for writing the state of a Java class to a format that is easily streamed, meaning that it's generally intended to be used for things like writing over an HTTP connection and so on. Contrast this with what Android needs, which is a serialization or a marshalling format that can be used to share data via block memory transfers. It's actually kind of a very different thing, so for one thing, the structure of the Java serialization format doesn't really lend itself well to use with binder, and also the serialization standard defines semantics around what it means to be serialized, and there's methods that serializable objects are allowed to implement to do a transform and so on. So because we can't support all those semantics, or at least we didn't want to try to support them in the first version, that's why we don't have Java serialization as a supported mechanism for passing data through the binder. So then the final class that I want to mention is just the bundle class. A bundle is simply a type-safe map, and that it boils down to that. The reason that in onCreate and onFreeze we didn't just use hash map is because hash maps are limited to either single type data, meaning that you're using generics and you say, hash map parameterized over keys of strings and values of strings or something like that. Or you use them as typeless buckets to store, say, like an object. The problem with both of those is that it allows developers to put data into the bundle that the binder can't actually serialize. And so instead of using a hash map, we use a binder, which is our own class, which has a whole bunch of really obnoxious methods like, get int, put int, get string, put string, get double, store double, and so on. And we do that because it needs to be type safe so that we can guarantee that the only thing that developers can put into a bundle is something that the binder can serialize. And then, of course, just as a quick note, I'm not going to go into detail on the Android interface definition language, but this is essentially what, as a developer, you would use to build your application, or what you would use to build a service and expose a developer-friendly API instead of, a messy kind of thing. All right, so that's basically all that I had today. Just to kind of give you guys a sense of what I'd like you to take away. I hope that what you've got a sense of what your tools are. That you've seen some of these things and you understand what they're for, what they're intended for, how they can be used. So I hope you understand your toolbox, and now you'll know which questions to ask, where to look for documentation, when you actually need to use some of these features. And then if there's one concept that I want you to take away, it's just this, that Android APKs are just collections of components. And the system does a whole lot of work in trying to make the interactions between components transparent to developers and transparent to users. And we don't make any secret of the fact that there are some seams there. There are some joints, and now I hope that you guys understand in a little more detail how those seams work. So that's it. That's all I had. Thanks for coming today. I'd be happy to take some questions, and I guess we've got a microphone there and there. So if there's any questions, I'd be happy to take some. Thanks. Start over here.
Hello? Okay. How dependent is Android on Dalvik VM? Because from what I saw today, you could have another Zygote process that could start JVMs instead of Dalvik VMs and use class files, not Dalvik files. So is that even possible?
No, it's not impossible at all. In fact, the way that I would phrase it is that Dalvik is not the only Android runtime. It's simply the first Android runtime. We're launching a new platform, obviously, and we're trying to, make it as easy as possible for developers to build applications for it, and that means making it as easy as possible for as many developers as possible to build for it. And so one of the largest developer communities out there and one of the most well understood is the Java community, and of course the Java community has lots of excellent tools like Eclipse and so on. And so, we just started with Java as a way to, reach a lot of developers. Dalvik itself is... does not run Java bytecode. There's a translation phase that occurs to translate Java bytecode into Dalvik bytecode. In fact, one of the design criteria for that bytecode format is so that it can hypothetically run languages other than Java. So if you wanted to, support some other language, it should not be. I'm not going to say it should be a big deal, but it should definitely be possible to write a compiler that knows how to compile some other language into Dalvik bytecode, in which case it would run perfectly fine on the platform. But to your specific question of using the Zygote, that's also a perfectly viable mechanism. You could do something like create a Zygote that starts some other virtual machine, like say, a Python virtual machine, and does a similar kind of warm-up approach. So the system, we haven't implemented that, but hypothetically it should work.
I rather meant, is it possible to have a JVM, not a Dalvik VM, you see, specifically for Java, not for other languages?
We haven't done any work on JVMs to do that, mostly because we can support the Java language through Dalvik. But if you wanted to do, if you're referring to something like a VM that you could use for pure J2ME applications, then that's also hypothetically possible. I don't think it would be very difficult to get running, but it's not something that we're focusing on right now.
Thank you.
Look over here.
Okay, I have a quick question on the naming conventions in the basically some of the names, like for example, bundle. That really got me tripped up because I thought I thought bundle, coming from an OSGI background, bundle has a certain connotation. Projections, I didn't really, from a content providers and projections or intents and intent receivers. I'm coming from a desktop background. I have actions and action listeners. I'm just trying to understand what was the thinking behind some of the names and how did y'all actually come up with those names, and did you get any feedback?
Yeah, a lot of the names are explicitly. So you're right. In some cases, there's name collision, namespace collision in some of the class names, and that's inevitable if you're designing an API. And in our case, what we're doing is different enough from most other environments, or at least many other environments, that we wanted to make sure that, in a certain sense, the developers went back to ground zero to learn it all. We didn't want developers to come in and assume they know what a frame is, or we didn't want people to equate a view with a control. We didn't want them to conflate, semantics of our framework with, say, the Swing framework or some other framework based on their name. And so in a certain sense, I'm not going to say that we intentionally made them hard to understand, but we did try and pick unique names. So a name like intent, for example. The intent is basically what you would probably call an event, because it's really just saying, an event to do something. But the thing is, it's issued in response to events, so it can reflect an event, but it's also used by somebody trying to start an event. And so instead, we just said, okay, we're going to call it intent because it represents an intention for something to get done. I intend that the browser be started with this URL. And so that's where the intent comes from. That said, some of the API names I think are probably going to change in a future version of the SDK for exactly some of the reasons you described. I think bundle actually is not changing, but I think a couple of the other class names might. Although none of the big ones, I don't think intent is going to change. So, question here?
Yeah, a map activity was what was the intent of that? Well, what was the purpose of that map activity to be created? Because it seems to be like with the activity, you could just make a map view and use the map view instead of creating a map activity. What was the purpose of that?
Yeah, that's an excellent question, and this one tripped me up the first time I used maps too. The map view is a view. So from the developer's perspective, it's just a view, and you can embed it in whatever arbitrary layout you want. The problem is that as views go, it's actually got a lot going on behind the scenes because it's doing that tiling stuff, where it's making back channel requests over the network to the server and so on. And it could, in some ways, do that by starting a thread, but it turns out that in the implementation of that, there's more to it than just that. And so to use the map view, there's a bunch of basically boilerplate infrastructure stuff that has to get started to use the map view. And so what map activity does is it basically kicks off all that infrastructural stuff that the map view uses to actually do the tiling and stuff. So it's kind of unfortunate because it means that if you've got an activity and you want to, like, say, inherit from list activity because you want to do something like that, map in the same view, you're kind of stuck between a rock and a hard place because Java doesn't support multiple inheritance and you have to pick one or the other. So yeah, it's a limitation of the API, and it can hypothetically or theoretically be fixed, but it was complicated enough that it's probably not going to get fixed before the 1.0 release. So, but that's something that we'll consider as a fix for a future release.
Thank you.
Hi, could you speak briefly in terms of background processing and process that we would build ourselves that would run in the background from start of when you start your phone all the way through?
Sure. So generally, background processing will be achieved through a service, and that's basically what it's for. So depending on what kind of background processing you want to do, I'm assuming that you don't mean like go do something while your UI busy waits, and I assume that you mean something like the example I gave earlier of playing an MP3 file in the background, or like implementing a synchronization thing for, I don't know, Microsoft Exchange or something like that. In a situation like that, what you'll want to do is basically what you have to do is create a service that can do all that logic, and knows how to do it, and via some way cause it to be started using a start service call, as opposed to the implicit starting of it when you just bind to it. Because in a case like that, you need it to be started as soon as possible and keep running in the background, regardless of whether there are any other components that are interested in binding to it at this specific moment. So that said, what you have to do is you have to make a start service call for the service to get it running. The thing is, if you're doing something that you truly want running in the background all the time, like an Outlook or an Exchange sync service or something like that, what you need to do is make sure that it starts up on boot. So what you can do is, and this actually gets into the notion that I mentioned earlier, where activities I mentioned are execution contexts. An execution context is basically something that lets you do things like call start service on a service. And so another common execution context is the one that intent receivers are provided. So what happens then is you can write an intent receiver that goes to its context and calls start service to start up your background Exchange service. And then, in fact, the final point in this loop is that there's a boot, or when the system boots up and the runtime has completed its startup, a global intent is broadcast that says, hey, the system is up and running. And so what you can do is your APK can create an intent receiver that hooks itself into that, hey, I'm done booting intent, and then when the intent receiver is executed, which will be shortly after boot up, it can then start your service to do your background sync.
What prevents from the process being actually terminated or going on pause, like you suggested?
So like when will the service be shut down?
Yeah, we don't want the service to be shut down at all.
Yeah, so you can either shut the service down by an explicit call to stop service. And so in a case of, as an application developer, you might make an activity and link it into, say, the settings menu or something like that, where you can go in there and say, turn off the sync service. And then that you can call the stop service on it, so you can like toggle it that way. And the other scenario in which the service will be shut down is if the system decides it needs the memory, which would be a pretty dire circumstance, and the system tries very hard not to have to kill services that way. Oh, actually, a question here.
Yeah, when you want to make a phone call using the telephony API, that's there. But if you want to see all the bits that the phone sees, how soon would that information be available?
If you want to see all the bits that, I think I missed that.
That the phone sees. So, if you got the phone waiting for a phone call, you set up the phone so that when it sees the correct data, it's, with the telephony API, it's going to respond. Instead, though, you want to see all the bits that the phone sees, everything, not just what only specific is going to trigger that specific phone call for that specific phone.
Okay, so do you mean sort of specific to the telephony API or just kind of in general? Like, basically what I'm getting at is, are you asking if there's a way to like register a global intent receiver that gets fired for every single intent that goes through the system?
Not so much necessarily fired, but so you just want to see all the data that the phone would see, all the different bits that are floating around that phone that the phone would normally be processing to look for the specifically information for its specific phone, its specific phone number and so forth.
Oh, are you talking about like the actual like radio so that you can do essentially like promiscuous mode on Ethernet?
Yes.
Good question. I don't know a whole lot about how that works. My guess is it's probably not possible. I'm pretty sure that the various cell standards are encrypted so that you couldn't decrypt the bits anyway. Like any two people's phones in here could see each other's bits, but I think they're encrypted. I don't know. That's my speculation. I'm pretty sure that's not possible in the API. But I don't know. Did anybody know the answer to that question? Sorry, that's something I don't really know.
Thanks.
The question here?
Yeah, I have an APK, and I have a remote service and a few activities in there.
Mm-hmm.
And I noticed that when I start the remote service, it actually starts as a separate process than those activities would run in. I think I noticed that.
So what do you mean when you say starts a separate process? Did you like use ADB shell and check it, or were you using, okay.
Yeah.
There are some cases, and you actually can explicitly request that a service be started in its own process. You can also actually do that with activities. You can also have an activity request that it execute in its own process, and you can even do that with tasks. So you can also have an activity request that when it starts a child activity that not be added to its task, but do it as a new task.
Okay.
So that said, there are hooks to do this. Without specifically seeing your code, I couldn't know if you used one of those or not, or if you found a bug or what. But definitely check it should be in your Android manifest files where you'd want to look for that.
It's not possible to have that remote service run in the same process as those activities, though, is it?
In fact, it should be the default to have a service run. Well, okay, let me just clarify and say, when you say remote service, do you mean a service provided by the same APK that your activities are in.
Yep, that's exposed to other APKs.
Right. So by default, they should be in the same process.
Okay.
So actually, you know, that's something, if you'd like, feel free to take it offline with me, and we can maybe see if we can figure out what's going on there.
Okay, one last question is, I noticed you can have a custom application class that you can declare in your Android manifest. And when you start two different processes for that APK, there are two instances of that application object.
The application component is actually something I'm not that familiar with, and I haven't seen it used much. So it could be that it's creating one instance per activity as essentially is owned by the context, or it could be a singleton. I honestly couldn't tell you, but that's something that if you contact me about that, I'll find that out offline for you.
Thanks.
I think we're just about up. I've got 20 seconds, or actually, no, I guess I'm 25 seconds over now. So again, thanks for coming. I appreciate your questions, and I hope you guys enjoy using Android.
Para ver si la cabeza me estalla. Yo no quiero que